This is the bug worksheet titled "What did the bug say when he hit the windshield?" And we're just going to go through a couple of the problems in each part so that you know how to do the rest of them, because they're just the same, just with different problems. So if we look at part 1 here, we want to match each graph, so 1 through 4, to the correct dilation scale. So these scale factors down here. Dilating from the origin. So that's just what we've been doing up to now. So if we look here, we have this small square in here, which is A, and this bigger square out here, which is A with a dash, which is A prime. So A is the original shape, and A prime, this bigger square out here, is going to be the new. So if you remember the scale factor, so that's right there, scale factor between two shapes when you dilate them is going to be equal to one of the side lengths on the new shape, so new, and it's going to be over the corresponding side on the original. So, and you can pick any two corresponding sides. Make sure they are corresponding sides, but A and A prime are both squares, so we can take the side length of A prime, doesn't matter which one because it's a square, and just count how long that side is. So 1, 2, 3, 4, 5, 6. So it's going to be 6 on top, and then the corresponding side on the original is just 2. So it's going to be 6 over 2. But if you look down here, none of these scale factors are 6 over 2, but we can simplify that. So 6 divided by 2 is going to be 3. 2 goes into 6 3 times. So now if we look for a scale factor of 3, we see it is right here. So we compared this side on the new shape and this side on the original, and we're able to get a scale factor of 3. So I'll put 3 up here. And then let's do another one. So let's do this triangle here. So number 3. So here A is again the smaller triangle, and A prime, which is the new shape, is the bigger shape. So we can pick any two corresponding sides. It doesn't matter, but it would be easier to pick one which isn't this diagonal, because it's a little hard to tell how long that diagonal line is exactly. But you could pick any two corresponding. So I'm going to pick the bottom side down here. So on the original shape, it's this one here. And on the new shape, it is this one here. So if we set up again with new over original, it's going to look like 1, 2, 3, 4 on the new, and just 2 on the original. So 4 over 2. And once again, you won't find 4 over 2 down there, but you can simplify that down to just being 2. 2 goes into 4 twice. So then scale factor of 2 is this one down here. So now that we know that 3 goes to T and 1 goes to A, you can come down here and write in those letters at those locations. So 1 we found matched up with A, so we can write an A here. And then number 3 here we found was 2, which matched up with this letter T. So scale factor of 2 was T, so we can write a T where we see 3. So that's how you do part 1. Part 2 is a little bit different. In part 2 we are given the dilation and the scale factor and the shape, and we want to find where a certain vertex ends up on the new shape. So here the original shape is ABCD, this square, and it's a little hard to see, but there is a y-axis and an x-axis going through the center of this shape. So write an x and y just so you can see where it is, because it's a little hard to actually see it on the graph. So let's take the first one here. So S, so the letter S corresponds with the coordinates of A prime, so where A ends up. So where does A end up? Well, we want to dilate with a scale factor of 2, and then wherever A ends up will be the coordinates of S. So you can either scale up the whole shape by 2, or you can just do the one vertex that matters for this problem, which is A. So to do a dilation, we want to multiply the coordinates by the scale factor. So the first thing we do is find the coordinates of A. So if this right here is the origin, then A is 2, or negative 2 in the x, and up 2 on the y. So A's coordinates are going to be negative 2 on the x, and 2 in the y. And we're dilating with a scale factor of 2. So we want to multiply these coordinates by 2, each one of them. So let's go with negative 2 at first. So negative 2 times 2 is going to be negative 4, and 2 times 2 will just be positive 4. So we know that A prime is going to be negative 4 on the x and up 4 on the y. So A prime will be up there. So then with that, we can come down to the answer and look for the coordinate negative 4, 4, which is right here on the end, and the letter S is going to go in there. So that's how you can solve those. If you're wondering why A prime is out there, well, you can do the same thing for the other corners. So B is at 2, 2. So you multiply its coordinates by 2, you can go out 4 and up 4, and B would be up there. So you'd end up, and you could do that for each corner, and you'd end up with a big square that would connect. That would connect all 4 of the corners, like that. And I don't have a ruler on me, so it's not going to look the greatest, but just, you know, trust me, it would look like a square like this. And so you can draw the whole square bigger, but if you want, you do only need to do it for the point it's asking about, which in this case is A. The other questions ask for other corners. It's the same thing over here with the triangle. So let's solve G down here. So the last question of part 2, you want to dilate with a scale factor of 1/3. So remember, when you're dilating with a fraction, it's going to end up smaller, just like if you were to multiply a number by 1/3. So it asks what are the new coordinates for A. So A is up here. And the first thing we want to do, again, is find the coordinates of A so that we can multiply them by 1/3. This time, though, the X and Y axes are on the edge of the page, not going through the center. So make sure you take note of that. X down here, Y up here. But now we can just count squares to find the coordinates of A. So A is going to be 1, 2, 3 on the X, and 1, 2, 3, 4, 5, 6, 7, 8, 9 on the Y. So A is going to equal 3, 9. And then when we dilate it by 1/3, we're going to multiply each of the coordinates by that scale factor, or multiply it by that scale factor, which is just dividing by 3. So A prime is going to equal 3 divided by 3, which is 1, and 9 divided by 3, which is 3. So A prime equals 1, 3, so it would end up right here if it was to shrink. And if we were to go down here, we can find 1, 3 and write in the letter G, because that was the letter that we were doing. And if you were to do the rest of the points, B is at 3, 3, so it's going to go down to 1, 1. And C is at 6, 3, so it's going to go down to 2, 1. So if you were to do all 3 of the points, you'd end up with this tiny little triangle down here. But you do only need to do A to find the solution.